Hey everybody, this is Larry. This is Advent of Code, day 23 with, with 50 seconds to go to start. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this today's challenge. As usual, maybe I need to edit this, but the explanation is toward the end, so please skip forward if you're just looking for the explanation. But yeah, and this is me doing the live recording. Though I haven't been, I've only leaderboard twice, but I haven't been doing it live, so that's my reasoning. But the last couple of days been kind of rough, to be honest. So these are things that I probably should have been leaderboarding a little bit, even if like not high on the leaderboard. But I don't know. Some days it is what it is. But yeah, 10 seconds to go. Wish me luck. Wish you luck. And let's go. 5, 3, 2, 1. Ooh, another good one. I need a good library. Ooh. Longest hike. That is tricky. Shortest path is easy. Longest path is hard. Huh. Ham path. Oh, I mean, okay. Well. I think the grid makes it a little bit different, but okay, let's just do it then. Let's see. I don't know. Also, my neighbors across the thing are being loud. I don't know if I need to. But whatever. that's not what I want to do. I know this isn't complete, but just want to sanity check a little bit. Okay. Oh, right. I mean, it's more than that because what am I writing? That's up, down, left, right. Directions of this. Well, that's no bueno. It does stuff, but gets cut off. So this goes down. Yeah. Am I doing down wrong? Nope, I am doing down wrong. That's to the right, and then this is down. Okay. I am still doing up, down wrong. Fine. Forget the recursion limit. Two, 3, 5, 8. 118, a little bit slow. Now this part is the hard part. Maybe. But let's see if that works. Probably not, right? 154 is right for the input. I think I should have YOLO'd. I spent too long thinking on part 1, to be honest. But I know this won't run. This is NP. I'd figure out a strategy to do it. How many forks in the road are there? I'll let it run though, but I don't think that's possible, at least within reasonable time. Man, both days I'm just a little bit slow in part 1. Oh, and the recursion limit. I guess I should have had that. That cost me like, I don't know, 10 seconds to look up. And that may be the 10 seconds I needed though, to be frank. So, oh well. 6,000, but this would run forever. What do I want to do? What do I want to do? I want to do something like... I want to take a look at the data. Oh no, that just, what I mean is more than 2. 2 is obvious. I mean, that's every path, otherwise you can't get out. What's my part 2? Only 34. There are 34 forks is what I'm seeing. 2 to the 34 is still too slow though. But you gotta try it. I don't think all of these are possible anyway, so let's see. Okay, let's figure it out, Larry. Figure it out, figure it out. It would be funny if that was the answer, but it seems unlikely. Okay, and then now. Okay, yeah. And also, okay, yeah. Roll 2, 1, okay. Okay, and then now. Did that improve? Can I YOLO submit that? That would be great. 6.5. Alright, well, that's cheating, but I'm still gonna try to solve it, but I was just a YOLO, I don't know, like brute force YOLO submit, good luck kind of thing. But to be honest, that's this is just lucky, because if I had gotten it wrong, I would have gotten 1 minute penalty, and it takes longer than a minute to do what I'm doing now. Anyway, but that is just silly. How long did my part 1 take? Because I'm taking a break now, but not a break, but 9:32. So yeah, I guess 10 seconds would actually not have put me on the leaderboard, but it would have been very close. And I did spend too long kind of just doubting the brute force way. And the reason why the brute force kind of works is because you can loop back kind of thing. I kind of had this for a while too. So I could have gone earlier, but not that much earlier. I mean, when you're 10th, you can only go up like 1 or 2 points. So I think I'm happy with what happened. But yeah. Okay, yeah. Okay, yeah, let me get back to what I wanted to do and actually get an answer. I mean, this is okay. Yeah, cheating wins. This is why I leave it running sometimes, you know. Okay. I mean, this is my highest finish this year for obvious reasons. Sometimes you just gotta yo. You don't have to solve it for every case. You don't even have to solve it. You just have to be a little bit lucky, such is life. But okay, yeah, 4x. What am I doing? I'm still making an effort. I'm not gonna YOLO. I'm not gonna like just give up on it. But it is funny. I mean, I would take it obviously. I feel like I've been so close the last couple of days. I would take a free gimme. I'm a little giddy because it's just, I don't know, so undeserved. But you know, so much of life is you don't get what you deserve. So sometimes maybe it's not. It's fine that you know, that you don't get what you deserve in a good way sometimes. I don't know. I lived a very blessed life. I don't know what I'm talking about. I'm just rambling right now. I mean, a lot of people are really trying to solve it, though. I'm sure, and or maybe their inputs are a little bit unlucky, the way that they did it. Well, I mean, if this is my answer, this is going to run forever anyway. So, like, or it might not end, but it's not going to update because that is my answer. So, okay, yeah. So okay. Oops. Queue up. distance, and then basically, oh, what am I doing? Only 30 or something. I'm too lazy to rewrite this. We don't continue. What do I write? B. No. I'm writing a lot of unnecessary O of N stuff, but it's just 34 points. I'm too lazy to rewrite it. You could write hash tables and stuff, but yeah, I think this is a metric, but oops, not like that though. I mean, this is a metric, but I'm just lazy. Okay. Where did I never close it? Kind of expected, but oh, I think that I messed up though. I think this is just all back to itself. Okay, yeah. That's why. I was like, this one's pretty fast. It should still run pretty fast, but not like that. 01 to 1515. Oh, let's look at the test. 01 to 53. 01 53, so that's 1 2 3 4 5 7 8 9 10 11 12 13 14, and including the first one's 15. Is that it? 2 3 4 5 6 7 8 9 10 11 12 14 15. Okay, so 15, that's right. 20 20 22 20. I guess that's only path. Oh, I missed this one. This actually goes to this one, not the thing. But all right. Okay. I mean, I think this is probably fine. But yeah. So you're trying to go from 0 to yeah. Now for, and I write this very sloppily, but if m of x to x is not infinity and not done of x, then yeah, I'll do the same thing before. I mean, I know I can maybe do a little bit better, but x d plus m of index x. And it's still running, but I mean, yeah. that part is not unexpected. Index is equal to 1, print d. Just kind of, I guess, best is equal to, oh yes, less than D, best is equal to D. Right. So same code as before. Something's a little bit wonky though. Oh no, I just had an extra print. And this can work just much faster for obvious reasons, but it's still 2 to the 34, so that's going to be pretty fast, pretty slow rather. I don't know how I've done this. Like, I just sit here and wait until it. I mean, it got to most of the answer pretty quickly, but. Oh, wow. I mean, that's it. That's done. So actually, it's not that bad. I guess there's more self-pruning. I mean, that's what I was hoping for. So I would have been done anyway. How long would I have been if I didn't cheat? Let's see. What is the leaderboard now? So I mean, I would have been top 40, which is, I think, where I would have expected myself to be, give or take. In general, not necessarily this problem. This problem, Q1 I should have done a little bit better, but Q2 kind of cheated me on top, so I don't know. Yeah, I mean, 30 seconds is fine, right? Like, I've gotten it now. I mean, I also took a pause to kind of like, I was like, oh, I submitted this, I'm done. So maybe if you could subtract a minute, but I mean, I don't know. At a certain point, it doesn't really matter, right? Like, maybe I would have moved up like a couple of ranks, but not that much more. And I didn't have much debugging today, which is actually pretty surprising, but maybe good in a way. But yeah, it took 30 seconds to run, so not bad, not that bad. Yeah, I mean, I finished it anyway now, so I think it's would have been 50, you know, top 40 or something like this anyway. But definitely still, you know, a challenging one for sure. Sorry, I know that I haven't been explaining. I mean, hope Kevin Wine gets it. I think he's a leaderboard buddy. Oh, didn't know Epiphany is doing pretty well this year. Pops. I know anyone else? I mean, there's some famous people, but I don't know if I would consider whatever. But alright. How did I? What was my sister? Yeah. I mean, I wasn't. I have to check how long I spent doing nothing, because I was just like debating coding it. If I just YOLO'd it, I probably would have gone like a minute or two faster. That would have been an extra couple of points. Still nice. How much at 120, 170? So I mean, I skipped most of the first, I mean, the ones of the 10 hours I was still in Taiwan. So for skipping like 14 days or something like this, maybe 15 days, and this one I was late, I think. I mean, I don't think I would have leaderboard though, so that one maybe you could count it anyway, because but yeah, and some of these other ones I might have leaderboard, but I also like, you know, like I was going hard, but not maybe super hard. I don't know. But yeah, let's go over the explanation for yeah, the 20. So part 1, right? Definitely let me know in the comments if I'm. Sometimes I just kind of hand wave some basic stuff, but to be frank, you know, like if you watch my other videos, I go over a lot of the same concepts, so sometimes I just assume my audience is the same audience, but it might not be, right? Which, my apologies. I don't mean to exclude anyone. And it is my video is probably not as beginners friendly as it could be. Usually my target is that you have to on my other videos anyway, 9 red of code, so I have to still calibrate a little bit. But basically part 1 is just I want to say branch and bound, but I didn't even bound, I just branch, which is basically brute force, try every possibility. And the reason why this kind of works, and this is what I was kind of trying to prove during the first couple of minutes, which wasted me enough time. And this is maybe part of the rustiness and stuff. Just like I think in especially with Advent of Code, I wanted to lead a bot, you have to YOLO a little bit, because even if you're wrong, unless you're like wrong in a weird direction, if you're wrong but you can calibrate it, it's probably fine. And for part 1, you don't have time to spend like 3 minutes on a proof, as you see. But anyway, for part 1, I just kind of brute force. And brute force, I mean, like, I try every possibility. And the reason why I hypothesized that this worked, though I didn't prove it, and I kind of idled for too long doing that. The reason why that works is because you cannot go up slopes. And because you can't go up slopes, I was hoping that there's a natural bounding thing, right? Because you can't go backwards, so it really just like limit the number of paths you can go up and down, or just find they just limited the number of paths that you can explore, because a lot of these paths are going to be one directional. So even though it is more recursive depth, it is not, I mean, they're recursion, but a lot of the time there's no branching, right? It just goes one direction. And I guess there are enough of this that, and we can maybe actually play around with how many branches there are. Or like we could play around with, like, come to 1, then we do maybe branch 0, 0. I'm just curious actually how many times it actually branches, right? Yeah, okay, that probably could have been an F string, and I think I voted like a F string, but not really. Right? And yeah, did I write that right? 922 seems more than I thought it would, to be honest. That is not possible. Do I have count in a different thing? Like, there's no 18 branches on this one, is there? Actually, this seems very weird the way that I wrote it. Give me a second. Sorry, friends. Trying to give you a good explanation, but this is me trying to explain away the intuition. What am I printing? Oh, D. Oh, I see. I see. I see why. Yeah, because it doubles up a lot of the other ones. Oh yeah. Okay, yeah. So basically the idea, and maybe this isn't a good representation. Right, let me rewrite it. Let me rewrite this so that yeah. running a lot of things to prove here, or at least to kind of validate the input set, but yeah, so there's only 8 branching points, right? And what I mean by branching points is decisions where you have to choose between going left or right or whatever, right? Like there are only 8 points where you can branch, and the way that I wrote it, because it duplicates some work, so it's not a DP thing. That's why it's kind of awkward. But yeah, so for the test case, I gotta stop putting so much. Yeah, for the test case, there are 8 branch points, and for my input, there's 35, which is, and actually, is this right? Yeah, I think this is right, actually, but that is surprising that this is more than the other thing, more than part 2 branch points. But in any case, yeah, there's only 35 branch points, and a lot of them are self-pruning, right? So you don't, like, you can't go, if you can't go backwards, obviously, so you can, like, and you can't do like a loop type thing. So there are a lot of self-pruning things, but there's only 35 branch points, so my max is going to be 2 to 35, and that's basically the idea that I operated on. Or, at least it was enough for me to YOLO for part 1, and then it just brute force, like, you could see the code, and maybe I didn't go over the code too much. The code is just really kind of brute force in a way of yeah, just print out the best as we get them. Did I modify this for part 2? I think, what did I do for part 2? That's different. That would be different on my brute force. I think I just took this out, right? I mean, it took a while, and it's still running actually. But yeah, basically this allows me to do the slope direction things, and yeah, this is just regular depth first search, a grid depth first search of following the directions, right? So you have the directions of up, down, left, right. If there's a slope, if we're currently on a slope, you're constrained to one direction, and then you just kind of look at the next cell and then kind of go on, make sure that we track things as seen so we don't go backwards or revisit the same cell twice. And as I said, there's only 35 branch points, and even then, that's and not all of them are possible to visit at the same time. So it's not a but it's a good enough bound for me to kind of YOLO, and that's basically what I did for Q1 or part 1. Part 2 is a little bit tricky. Basically, the idea, and there are 2 ways to do it, at least. The way that you kind of saw the way that I did it was, I think I comment this out and then I run part 1, and that's basically just what the problem asks, right? Yeah, that's basically what the problem asks. The problem now is that a lot of the branch, like now it's, we said that 2 is 2 to 35 kind of, but a lot of the branches are not possible because you cannot go backwards. A lot of the actual graph is not connected because you just can't go to a lot of places, right? But once you can go up slope, apparently it is way more complicated, as you saw, and we have to do a little bit better. And the way that I did it is still brute force, to be honest, but it just compresses the brute force so that you could call it a path compression, I guess, even though that means something else in different context. But the idea is that, okay, now that we call a branch point, of course, is just a point where you can go left or right or up, down, left. Basically you have a decision to make, right? If you're not at a branch point, you have no decision. And what I mean by that is if you're going from left to right, there's no decision, right? You have to go right. You have to keep going forward because you can't go backward. You can't revisit the same thing twice. This is a grid. And also in the general case, this is NP complete, right? This is Ham path, Hamiltonian path. Yeah, Hamiltonian path. Yeah, it is Hamiltonian path. I mean, I guess you can say stuff because it's unweighted, but yeah, it's a Ham path, right? well, it's not technically an M path. I guess it's the most whatever path. But either way, it is really NP in the general case. However, in this one, it is a grid, and there's a lot of constraints in grids that are kind of just like by itself, right? And for this one, like I said, if you can go left, go right, and this is all corridors and mazes, and so there's no like open spaces where you have to choose like which way to make the mazes and which way to fill the gap. If you do, then that would be, well, just way more complicated. But yeah, but in this case, so and if you watch the live portion, I did do a thing where I just kind of counted the number of branch points we had. I didn't really prove that on part 1 because I was just watching YOLO. But for part 2, I was like, okay, well, there's only 35 points or 34 points. Again, 36 if you add the 2 beginning points, or the beginning and the end. And then I basically do a breadth first search from each of those points. It is kind of symmetric, so I probably could have done less work, but it doesn't really matter. This is not the expensive part of the algo. Because basically, if you don't want the expensive part, yeah, this takes 0.1 second, so it's not even worth optimizing, right? Like optimizing away an n where n is 35. In fact, I do a lot of expensive stuff in some parts of this. Like you say, like this is O of n for no reason, but like I said, this is 35. But yeah, but otherwise, it just becomes okay. Now we have a matrix. And I could have actually improved this a bit because not all of these are connected. You can make this in because it's not a very dense matrix, so you can probably use a adjacency list. But I don't suspect it optimizes that much. Maybe we could, maybe we can play around with this now to kind of see how it optimizes. But yeah, but now that happens, now it's just, you have 35 points, a lot of them are not connected, so you just kind of brute force the way around that, and that's basically the idea. Let me take a look to see how many edges there actually are. So for x in range of R, for y in range of C, if m of xy is equal to or not equal to infinity, equal to 1, right? Did I do it wrong? Oh, whoops, this is not, this is n. Yeah, 156 total edges. So, what does that mean? That means that in theory it could be very long because the edges are really well, not really, it's hem path, but so it'll be bounded by whatever. Even though it is rated and you're trying to find the longest path in a graph. But yeah, I mean, sometimes you just kind of do things and pray. And also at this point, to be honest, I already knew the answer because I YOLO submitted the first half. So I was not that, under that much stress or whatever. And I knew that, I could just let it run. Though 30 seconds is a little bit longer than I would like. But I mean, you could optimize this a little bit. It would take me more than 30 seconds to optimize it anyway, right? So yeah, so maybe you could do y is equal to this, right? For x in range of n, I guess we already kind of did have that loop, right? E of x dot append y m of xy, right? So now you have an adjacency list, and then now you can optimize this to just say, no, not for x, let me just comment it out so I can have it, xd in e of index, right? And that's pretty much it, right? That's the optimization. Let's see how much faster it is. It may not be, or maybe I also may just do it incorrectly. So yeah, actually I think no, I mean I think this is right. Yeah, maybe this is right. Let's see. I mean, I realize it just takes half an hour, right? Oh, it's half a minute. So yeah. So yeah, so it optimizes it to 7 seconds, which, like I said, it would take, well, it would be nice if you print out the answer though, right? So maybe this is not quite right. No, I think it's 102 is the answer. Why? Technical difficulties, hang on. What? Tell me why. Well, it's a good thing that we didn't do it this way then. We used D by accident. We don't even use it, so okay, fine. Yeah, so still the same timing though. Just I shadowed the variable again. But yeah, so we can optimize it to 7 seconds, which is very reasonable. Yeah. And this is in Python, and I don't use PyPy or anything, so I'm sure in an actual compile language will be even faster. But yeah, otherwise this is still brute force. We just did path compression for part 2. And yeah, that's all I have for this one. Let me know what you think. And yeah, congrats to Larry. I mean, it's nice to at least have one good day. I mean, how many points do I have? 120, 170. So I'm not even close, right? I mean, I gave up 10 days or whatever at least, so that would have been pretty okay. But yeah, it's nice to kind of have one high leaderboard. Anyway, that's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.